Ways of studying the brain, right? This is what we're going to be looking at. Hello, by the way. Ways of studying the brain is what this video is going to be about. A really kind of classic describe and evaluate bullet point. So you need, I'm going to move because it's quite echo in here. You need to know, I'd say at least 4 ways of studying the brain. We're going to provide you with 4, but these are not necessarily the 4 you need to know. So the ones we're going to look at today are fMRIs, known as functional magnetic resonance imaging, which is this kind of machine in the top right. We're going to be looking at EEGs, ERPs, and the physical version of post-mortem examinations. So you need to be able to describe and evaluate all of those, and not just be able to describe and evaluate, but know the technical ways in which the scan works. So we can look at your brain physically, we can look at your brain through a scan. You can talk about MRI, PET, or CAT scans if you wish. These are scans we're not looking at today. They're probably harder to get marks from. So you probably want to just stick to fMRIs, EEGs, ERPs, and postmortems. So let's start with fMRIs. Right, on this GIF, you can see the brain just here, for example. You can see the eye just there. You can see the cerebellum there. You can see the limbic system over here. And basically, the fMRIs is a non-invasive, see the other eye there as well, a non-invasive method that doesn't use radiation, quite important, and we can view the brain without having to crack the head open. So you do need to know the technical ways in which it works. So basically fMRIs, and I will see if I can show you. No, fMRIs are basically these type of scans. A few of you have been, inevitably, a few of you have been in fMRIs. Most of you, it's not that you hate it, but you probably didn't like it because it's literally a claustrophobe's worst nightmare. You lay on this bed goes into the machine, and some people actually really like it. They like being like snugged in a way, but you have these frigging massive magnets that move around and around and around. And what the magnets, and you can hear them moving around. Promise me you will not like leave in a belly bar or something if you go into fMRIs, because it will probably get ripped from you if you forget it. So make sure you don't take anything metallic in there. Your watch will, your hand will get slammed. But anyway, the ways in which they actually work is by using this magnetic field, removing it, and measuring the hemoglobin that is released after you remove a magnetic field. So as a result, kind of as it says here, when a part of the brain is being used, it requires more oxygen, and the fMRI can measure that oxygen usage quite accurately. So it's a really clever way to measure. Now, you may not understand how that works. Ideally, you would. You just need to know that is how it works. So it measures the energy released from hemoglobin after a magnetic field is removed, and from that, it can actually map a 3D picture of the brain, also identifying dead areas because there's no activity going on there, and that would show up as kind of black dots on the scan. fMRIs can be used as in terms of identifying what part of the brain is being used. So if you're in an fMRI, for example, I could say, right, Jasmine, I would like you to think of a really traumatic childhood memory. And I could then basically see what part of your brain lights up like a Christmas tree. It would be your amygdala, the emotional center of the brain. And then I could infer that, okay, that part of the brain is for negative trauma, for example. I could get you to do spatial tasks in your head. I could get you to picture the word K, and you're just spinning the letter K round and round in your head. I just want to hold that in your head, see what part of the brain lights up, like a firework, for example. So it's really, really good for localization studies, for example, in determining what part of the brain is active at a particular time, but it is also remarkably accurate. So fMRIs they have very, very, very good spatial resolution. Now, what that means is, and it's a tricky thing to be able to describe, I guess, spatial resolution refers to how many pixels are in a scan. So if you've got more pixels, like a TV, for example, you're able to get a more accurate, defined image. So an fMRI is packed full of pixels to the point where you can actually measure down to the millimeter. You can accurately measure down to the millimeter. So in terms of spatial resolution, which is what we're talking about, it's incredibly accurate in terms of the picture it provides. It's not so good in temporal resolution, which I'll come to in a second. But that's all you need to know for fMRIs, apart from the evaluations. So on the good side, it actually gives you what we call, and use this term please, it gives you a dynamic image of the brain. It shows the brain in action. It's not taking photographs, it's creating a video of your brain in action. What do you think is much better in this regard? To film the brain working or to take photos every 2 seconds? Clearly the film is better because you can see it in action. So the fMRI is very good from that point of view. And on one hand, it is very objective, right? The scan is not lying to you. It's not giving you its opinion. It's telling you for a fact this is what is happening in the brain. So it's not that there's no subjectivity in the scan. However, it becomes subjective as soon as the doctor tries to interpret what it may mean. So you've got to be careful here with how you say it. You can't say that the scan is subjective. It's not. The doctor's interpretation is the subjective part. So you could use that as a praise for its objectivity, or you could use it as a weakness for saying, whilst it's objective, it's still subjective to a doctor's interpretations. They are expensive though. Right, they're very, very expensive, and I've got a statistic here for the range of them. But keep in mind that hospitals struggle to pay for fMRIs quite a lot. They are incredibly expensive, and this is an easy bullet point to compare. I probably have wanged on a little bit in lesson, and maybe other teachers have as well. But these are really, really good bullet points to compare. So you could compare fMRIs and say they are notoriously expensive to EEGs. fMRIs range from 860 grand to the good ones. When I did this research about a year ago, were 2.5 or just short of 2.5 million, right? Whereas EEGs, maximum 20 grand. Maximum 20 grand. So you would want to compare them on price. Why is price a bad thing? If you got the money, you got the money. Well, the reality is that you can only fit one person into an fMRI. And to be honest, you can't even do that sometimes. You've bought this very expensive piece of kit. You can't buy another one, and therefore the samples you get from that are going to be quite small. Whereas if you've got 60 grand, you can buy 3 top of the range EEGs, and therefore you can get bigger samples quicker. So a problem of fMRI is that it is too expensive, and you can't get big samples from it. Now, as I've said already, it does have great spatial resolution. Right, as it says, it means the scan is packed with more pixels, which allows for a more accurate image of what is happening. It's not like a 1970s TV show where you can't really see what's happening because the camera is so crap because it doesn't have that many pixels. The problem with fMRIs is that whilst it has fantastic spatial resolution, it has awful temporal resolution. And what we mean by temporal resolution is the extent to which the scan shows you what activity is going on at that exact moment. Does it have a delay? With fMRIs, it does have a big delay of anything from between 1 to 6 seconds. So you're asked to do something, and then to think of something, for example, that thought is not going to appear on the fMRIs for up to 6 seconds. Now, why is that a problem? How do you know that that thing that changed on the scan was a result of what you asked them to do? You can't, because there is big there's a lack of temporal validity. So ideally you would want, right, I'd want to think of traumatic childhood, right, go ding, and you'd be able to say, right, clearly that is because of that. But you don't get that with fMRIs. Now, that's the first one. There is a model peel here. And by the way, this is how you would write that point about it having high accuracy. So you don't just go, oh, it's got, high spatial resolution. This is how you would write that point. Please make a note of this, because you are going to be asked this at some point, I can guarantee it. EEGs, electroencephalograms. Now, as you can see, this is not a machine that you go into, it's a machine you put on your head. And as you can see, it's not a moving image. It is a little bit, it produces what looks like, but Richter scale, kind of like earthquake things. Now, each of these lines is one individual electrode. And you wear this cap on you, sticks to it, and the electrode measures the general electrical activity immediately under the electrode. So as you can see, there's no electrodes in this tiny space here at the front of his head. Therefore, they're not actually measuring any electrical activity there. Therefore, is it accurate? An fMRI would catch that. One thing to note, the more electrodes, the more accurate. Right, the more electrodes, the more accurate. I'm going to show you another one just here. We'll come to ERPs in a second, but this is maybe a better picture. Again, there's nothing here. So really, you want to pack up as many electrodes as you can. But that's more expensive, by the way. That's more expensive. The more electrodes there are, the more accurate it is, the more expensive, the more Elizabeths you have to give up. So in terms of EEGs, because this is where it gets confusing, if you have a look, EEGs and ERPs use the same machinery. It's exactly the same apparatus. Apparatus? Apparatus? It's exactly the same apparatus, but it's how you use it that's the difference. So EEGs, this is pretty much all they are. They measure the general electrical activity, and they can cost from anywhere between 900. We should save up and get some, shouldn't we? That'd be pretty fun actually to be able to use in class. Anywhere between 900 and 20 grand. The £900 are the cheaper ones. The electrodes aren't as good, and there aren't as many of them. Now, if EEGs measure the general electrical activity, ERPs they use the same apparatus, as we say, and they use the same apparatus, but they measure the electrical activity after a planned stimulus that is presented to the individual. So EEGs, you just measure what's going on generally, and you might be able to pick out any abnormalities that are occurring in the brain. An ERP is when you put it on the head, and then, like the fMRIs, you say, okay, Yasmin, I'm not being creative with my names today. I would like you to think of a 3D cube in your head. And then you basically see what electrode changes, what electrical activity changes in the brain, because that would suggest activity in the brain. And that's pretty much ERPs, to be honest. So again, it's relatively straightforward. Now, in terms of evaluation, the great thing, you're not splitting open anyone's head, which generally is a strength for most things apart from splitting people's heads open. So it's non-invasive. It's also, by the way, non-radiation. And again, that's quite important. Some scans, like PET scans, and just think about how mad this is, PET scans inject you with a radioactive tracer into your blood. I think it's like radioactive gold they put into your blood, and then the blood goes into the brain, and basically it then starts mapping your brain as the blood goes around the brain. It's incredibly clever, but it has radiation in it. Whereas EEGs, you don't want, it's like X-rays, you don't want the radiation, basically. It's non-invasive. It has strong temporal validity. So unlike fMRIs, the electrical activity shows up immediately after think of the behavior. So it's fantastic temporal resolution, but awful spatial resolution. There's too many gaps. There's too many gaps here, which lessen the accuracy of the scan. It's cheap compared to fMRIs, and we've kind of spoken about that already, but you can use it, flip it around. But here for me is one of the biggest issues, especially when compared to fMRIs. Yes, the outside of the brain, called the cerebral cortex, is the most important part of the brain. It's literally what makes you human, right? Fine. But the EEGs and ERPs only measure the outside. They do not measure the structures or the regions in the deeper recesses of the brain, i.e., the stuff we've had for longer. Your amygdala, for example, your whole limbic system, your cerebellum, not particularly. So you could argue that lessens the validity because they're only measuring part of the brain. Yes, it's the most important part of the brain. Absolutely. It's the part that makes you human. It's the part about thinking. But they don't measure the inner recesses, which I personally think is very, very bad. Lastly, we could get physical with this. Now, please do not write in your evaluations that a positive of post-mortem is that they don't feel pain because they're dead, right? That's not a positive, right? Please do not write about you can't get consent from a dead person. No, of course you can't, you idiot. You have to get consent from the family, and you would obviously do that. So, sorry, I've got some unresolved issues with this sort of answer. But post-mortem is old school. Old school. Why do a scan when you can get your eyes on the brain by cutting their head open after they die? So there's major problems with this, but it's the only one that actually gets physical eyes on the brain. Damage can often be seen, and you do kind of need to know Broca and Wernicke's case studies because they're really good examples about how post-mortems have really helped us in our understanding of the brain. So Leboeuf, also known as patient Tan, was Broca's patient, and he had massive damage right across his Broca's area, real bad damage. And the guy couldn't talk. Well, he could talk, but the only word he could say was Tan. And so Broca correctly surmised, nice use of the word surmise there, Kieran, well done, correctly surmised that, he's got damage there, he can't talk, therefore that region must be for the production of speech. And he literally, arrogantly, called it Broca's area. So imagine being that arrogant to name I'd love to be able like the Shipley Centre or something like that. But anyway, so you do kind of need to know this. A crucial element, and you need to write this down, for post-mortems to be effective, you need to know about the behaviour of the deceased individual in order for you to make any links to any potential damage. So I'll say that again. In order to link any potential damage to behavior, you need to know about the behavior. You can't just have some random dead cadaver on your table and then make wild assumptions. You need to know about the behavior of it. So without knowing what the patient was like when they were alive, it would be impossible to link behaviors to damage in the brain. And Broca knew of patient Tan's speech impediment. So in terms of model answers, yes, you may argue that they are arguably more unethical due to its need to be physically invasive, especially when compared to fMRIs. So this is a comparison point, and this is how you write comparison points. You'll notice that you've got both parts of what you are comparing in the point. And then you go, on the one hand, post-mortems, and I'm going to provide evidence. So post-mortems require a physical and invasive examination, and this usually involves making incisions into the brain, which may be upsetting for family members despite any consent given. On the other hand, fMRIs are non-invasive and harmless. Participants simply have to lay still whilst their oxygen consumption is measured, link it all back. Therefore, the differences between these scans is apparent when considering how ethical and invasive they are. That's not the best comparison point, but structurally, that would, I think, be considered a strong point. Right? Remember, in your point, you have to make reference to both things you are comparing, otherwise, you are not comparing. Couple of questions, but to be honest, prep for everything. You may get a simple multiple choice, or you may get a 16 marker. There is a lot to this. You need to be able to compare any of the two. You need to be able to compare any of the two strengths and weaknesses, similarities and differences. But overall, I would want you to go into the exam knowing all four. Hope this is useful. As always, click, like, subscribe. I hate myself so much.